Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from First Block. Okay. And in this video, we're going to be working with these homework number 3. However, we're going to be able to do this together using those same ideas that we've had before from those equations. So again, make sure you're using the equations foldable for yourself. That way you can say, hey, what am I supposed to do first? Well, you always want to make sure you're doing that distributive property, combine like terms, and manipulate the variable. So again, since we have parentheses, we're going to use that distributive property. I can draw the box on the side, so I have 3 on the outside. I'm multiplying that to each of the inside terms on the inside the parentheses. So I have positive 3 times x is going to be 3x, and then I have positive 3 times 6 is 18. I write that below where I multiplied. Everything else stays the same. So bring down the inequality, and I'm good. Now I can subtract both sides by 18. On the right, it cancels out, and we have 3x, and we have negative 3 on the left. Again, divide both sides by the coefficient, so divide both sides by 3. Did we multiply divide by a negative? No, and so it stays the same, and so we're going to have x and then negative 1. Be sure to have your variable on the left side, so make sure you flip the entire thing. So we're going to have x is less than negative 1. When you go to graph it out, again, you want to have an open circle now. So no filled in line, no filled in circle. I'm going to have an open circle on 1, and I'm going to be shading everything into the left. Hello, Shank. Yes. Yes. Yep. Bye. All right. So now, on that second one, it says circle all possible solutions that for the following inequality. So that means if it's a possible solution, it would be a true statement. So we're looking to see if we plugged in any of these values, would it still hold true? So again, we can solve it how we normally do. And so we're going to subtract 21 from both sides. On the right, it cancels out, and we're left with that negative 1/2 times x. And on the left, we have negative 15. We can write this. We can write this as a fraction, or a decimal. And so, if you want to, you could say, "Hey, I want to divide both sides by negative 0.5, negative 0.5." Since we multiplied and divided by a negative, now we have to change the direction. So we're going to have less than now. And on the right, we have x. On the left, we should have a positive 30. Be sure to also say you have x is greater than 30. Again, you want to make sure that that alligator is still eating the same way and it's facing the right direction. So we're going to say x is going to be greater than 30. So out of these choices, which numbers are strictly greater than 30? Okay, so we said 60 is greater than 90. We said, 60 is greater than 30, and 90 is greater than 30. Would we include 30 as an answer?
No.
Why not?
Because there's no line on the end.
So since it says strictly greater than, we're saying it's not equal to 30. So again, be careful on that. On the third one, just like the 2 steps that we've been doing, it has that we subtract. When you bump this down, we'll subtract 5 from both sides. On the right, it cancels out, and so we're left with negative 2x, and then we have negative 16. Again, divide both sides by a coefficient, which is -2. Did we multiply divide by a negative? Yes. And so we have to change the direction. And so we have x on the right and a positive 8 on the left. We want that variable now on the left side, and so we gotta make sure we are fluent with our flips, and so we have x is less than or equal to 8. Again, when you go to graph it, you're going to have look for that positive 8, and so we have positive 8, open or closed circle, closed circle. So we have a filled in line, filled in circle, and it's going to be everything less than 8. So I'm going to shade in everything less than and including 8. Is 0 a solution for this one?
No. Yes.
If so, why?
Because like 0 is included.
So yeah, you can physically see 0 is shaded in, and if you plugged in 0, it is less than or equal to 8. So you could say, yes, 0 is a solution. Okay. Any questions on that one? That was a simple two-step one like we've been doing. So now, however, this will most likely be one of the more complicated ones that we do. However, it is still super simple because we know how to do it. So, anytime you see parentheses, make sure you're doing that distributive property. And so we're going to have this. We're going to have our distributive property on the side. And so I draw the box, and I have on the outside is -4. On the inside, I have a positive x and a positive 3. So I do -4 times x is -4x. -4 times positive 3 is -12. Again, write that underneath, and so I have -4x minus 12. And then on the side, again, I can do my distributive property for the right side. So I have positive 3, and I'm multiplying that to each of the following. I have positive x and a -4. So I have a positive 3x and a -12. So I'm going to say on the right side it's going to be 3x and then minus 12. So again, since I have my distributive property done, what can we do now? We want to get all the x's to one side. So which coefficient is lower? Which coefficient is lower? -4 or positive 3? -4 is lower. So that's the one we're going to add the opposite to both sides. And so we have plus 4x to both sides. So plus 4x. On the left, it cancels out. Everything else comes down. So we have 3x plus 4x is 7x. And then we have the minus 12. Now that we have all the variables on one side, we want to make sure we can get all the constants to the other. And so we're going to add 12 to both sides. And what happens? On the right side, they cancel out. The 7x comes down. And on the left side, they cancel out. So what value should I write? Still 0. Still 0. Again, I have 12 negatives and 12 positives. Again, I can still divide both sides by 7 and it would still give me the same answer. And so I'm going to say x is less than or equal to 0. So again, I have a filled in circle on 0, and I'm going to shade in everything to the left, saying everything less than or equal to 0. As always, last question, is 0 a solution for this one?
Yes.
Yes, the very rare case that it is equal to 0. So you say yes, 0 is a solution.